Okay. All right. So as I was saying, we have solved the beta 1, we have solved the beta 2. And so what we need to solve now is R square standard error beta 1, standard error beta 2, and OU. In fact, this standard deviation square U of error is very easy. This one is the easiest among them too. Okay, so I will quickly do that one for us now so that it will now remain R square SE1. In case you don't even know the formula of R square, if you don't know the formula, at least you can do beta 1, beta 2, you can do standard error square, where B1 is constant, then you can also do C part. But I'm not saying you should not know it. So I will solve everything for you tonight. You know, we already use our original calculator, not those with fake calculator, to calculate RS, the R squared that time. The R squared is 0.9051. So I will calculate it with the real formula, and hopefully we should be able to get this answer for our R squared. So we'll do that tonight, okay? So, but I want to quickly, so now beta 1 is done, beta 2 is done. Okay, let me type out all those things so that as I'm doing them, you guys will know. Beta 1, done. Beta 2, done. Okay, SEB1, pending, we'll do it. SEB2, SEB2 is also pending. We'll solve it now. Then, which other one again? Error square, error of U, standard deviation of U is pending. So that's what I want to do now. Okay, so let's quickly take care of that now. So the standard deviation of U simply means that they just want you to prove your Y minus Y bar. That's what you have to prove, that the sum of all your errors is equal to 0. The summation of all your error squares is equal to 0. So let's do that now. So I'm going to insert table here. Let me insert a table here. So I will just reference them to the table. In our solution, we'll reference them to the table. So now, what is our equation? This is our equation, right? Our equation is simply what? Y is equal to 71 plus 0.443x. This is our equation. Y is equal to 75 plus 0.443x. This is our equation, right? Just a moment. So this is x. So now we're going to insert the value of x in each of these equations so that we derive our value here. So if you guys will permit me, I want to be very fast tonight. Can I just use Excel to plot this value? Or do you want to press calculator one by one? I want you guys comment, please. Can I use Excel to plot the value? It is faster for me in Excel.
Use the Excel.
Thank you, sir. So since you know, thank you. Since you know what I want to do, so I will just use Excel to plot the value because of time. I need to end my own session by, I need to end it by 10 o'clock. Yes, please. Yes, please.
Going to share the Excel file.
I'm going to share the file now.
Okay. And also the recording is not compulsory. You load it on YouTube. You can just share the recording like that.
No, if I'm able to download it, it's as good as on YouTube. YouTube is the easiest, but getting it out of, as I'm recording this, is going to an application called MS Stream. Getting it out of MS Stream is a while. YouTube is the easiest. Anyway, so because I'm actually not going to the office till Monday. So that's why I have the broadband. All this internet we are using at home here, they don't have that power to download all those large files. Anyway, let's see how far we can go, Sha. Okay, so okay. This one simply means I will be inserting my X in each of these cells, right? So I will use my Excel formula. Okay, I will use my Excel formula. What will I do in Excel? I will just say this is equal to 71.03. Oh, I'm not typing it. 71.037. Okay, plus then this value 0.1443 multiplied by what? Multiplied by my X, which is X. This is my X. So I'll close it. So if I do that now, so this is the value for this. Okay, so this value now, let me try and copy it. Let me see if I can paste it here. So we have gotten this value already. Yeah, done. Okay. So then the total is what? What is the total? Oh, why is my keyboard messing me up today? Just hold on, sorry. Apologies. I need some. Okay. I've seen the problem. It should respond now. Sorry, I'm having some issue with my keypad. My auto sum refused to enter, so let me just do it manually. So this is the total, 854 something something something. So this is the total of this, right? This is the total of my B cap. This is like my estimated of B. Now I need to calculate my Y minus Y cap. So Y minus Y cap must equal to 0 based on the rule. Y minus Y cap must be 0. So where is that? This is like sum of residual. That is what it means, sum of residual. Whatever figure we are going to be having now, will be the residual. So I'm wearing cap for this. Sum of residual must be 0. Anyway, this Y here, I'm having some issue with my keypad, so I don't know. Oh shit. And I don't want to restart the system or just let me just wait for it to load. My system is hanging. Oh God. Can you hear me, guys? Hello, can you hear
Yes.
me? Do you mind if I
Yes,
quickly
I can
restart the
hear you.
system? Do you mind if I quickly restart the system?
Yeah,
I've actually not shut. I've not shut it down for like 2, 3 weeks now. That is what I am.
no
That is the
problem.
reason why it says. Let me just. I'll be out for like 2 minutes. Okay.
No problem. We'll be here waiting.
Hello, so I'm back. Let's quickly fire on, please. I'm already run. I'm seriously behind schedule. I'm seriously behind schedule. So let's run. I'll be very fast now, okay? So because I have to stop this by 10 so that lecturers. Can you guys hear me? Hello, can you guys hear me?
Yes, we can hear
Yeah.
you.
Yes.
So I think my system is okay now, very okay. So as I was saying, I was trying to prove this for us. So this is going to be y minus y cap. You wear cap for your y. So let's quickly do that. Y minus, where is our cap? Oh, draw. So you wear cap for this. So if you do y minus y cap, so what you are doing basically is that you are subtracting this y from this value. Okay, you are subtracting. So let me use the Excel to do that also, so that I don't keep we don't waste time in calculating. Let me use Excel to do that So I'll just copy this table to Excel. Loading. So we'll do y minus y cap. So once we're able to prove that, then we are done with that. Use standard deviation of the squares and u. So we're done with that. So we're only left with r square, standard error of B1, and standard error of B2. So that is what we'll be left with. Okay, yeah. So, all right. So this is it now. So what is my y minus y cap? So basically, it is this now. So let me zoom it in case you can't see clearly where you are. Let me zoom it. So what is my minus y cap? So this is basically, it is my y minus this my estimated y. Y cap is estimated. So when you do all that, so summation of everything, all t being equal must be 0. Okay, summation of all this must be 0. So if we sum up this together, all t being equal, it must be 0. So that's just what we need. So 0.04, I guess we have done some approximation in between, but surely it must be 0. If because we are probably done approximation, that's why we keep having that 0.00 something. But this should be 0, technically speaking. All right, so that's it. So it should be 0, yeah. So I think with that we have been able to prove error of u2. So what we are left with now is the r square. So the formula for r square, I was able to do some research on ChatGPT. The man gave us ESS divided by, I think, RSS and TSS, but I'm unable to prove this RSS divided by TSS. So I had to consult the Oracle, which is ChatGPT. So what ChatGPT gave me, let me quickly write out the formula from ChatGPT. So I have my ChatGPT state what my summation. Okay, summation xy. So let me write the formula of ChatGPT for it. It's very easy. It's very easy. It might look slow long, but it's very easy. Summation xy minus 1 divided by n. N means number of observation, which is 10. Minus 1 divided by n. 1 divided by n, summation x, summation y. So you close the bracket, everything square. Close the bracket, everything square. Everything square like this. So this is what you have in your numerator. Then your denominator goes like this. Your denominator goes like this. You open a bracket. Summation x square, summation x square. That's why you have your summation x square minus summation x square minus summation x square remove now. Summation x square minus 1 over n again. So 1 over n. Summation x square minus 1 over n into summation x into summation x. Okay, this summation x alone, you square it. Summation x alone. I mean, raised to power 2, sorry. Then you will now repeat the same command for y. So this same thing that you've done for x now, you will repeat the same thing like this for y. So this thing now, you copy it, I'll paste it here. So I'll just say summation y square into this y. So this is the formula for your R square. So now that we've done this, now let's insert our variables now, the number. So our R square is equal to, what is summation xy from our table? Summation xy is this 94,999. Okay, 94,999 is that. That's 94,999. Then minus 1 over, our number of observation is 10. 1 over 10, okay, into summation x, summation y, each of them separately. Each of them separately. Summation x is 1002. Summation y is 8005 times 855 times 855. So everything now, everything, pata like this, you do power 2. Everything. You have to finish everything. So all together, the entire figure, okay? The entire figure, I mean, raised to power 2. Raised to power 2. Everything that you've calculated there, raised to power 2. So that is, once you have to do everything first before you now raise them over 2. Then divided by this, divided by what? Divided by summation x square. I open a bracket. I'll do summation x square. Where is my x square? This is it. So that summation x square is this 165 here. Okay, because that's what you have under for x square. So this 165 minus 1 over n, that's 1 over 10 is your n. Then summation x alone. Summation x alone, that's 855. Summation x alone is 855. No, summation, sorry, let me see. So 1 over n into summation x alone, that's 855 raised to power what? 2. Where is summation x? That, sorry, is 1002. 1002 raised to power 2. 1002, like this. Only this one, no, raised to power 2. Okay, so this is what you have. Then you will now do the same thing for y. Then you have minus summation y square. Where is our y square? Y square is 74. Y square is 74,589. Okay, this 74,589 is our y square. Okay, minus 1 over 10 again. Then summation y raised to power 2. Summation y is 855. 855. Then you raise to power 2. So raised to power 2. So these are all the variables, right? So if you solve this thing mathematically, if you solve it, remember that for this numerator, you have to first of all solve everything like this before you now raise it to power 2. You have to solve everything first before you raise to power 2. For this denominator, first of all, raise 1002 raised to power 2, multiply by 1 over 10, then you now subtract it from this. Then you will now minus it from this one also. First of all, you do 855 raised to power 2. When you have done 855 raised to power 2, multiply by 1 over 10, subtract it from 74. So when you do this one, if you do it correctly mathematically, you should be able to arrive at the figure. If you want to do it now, but because of time, I've actually done it on my own. I've worked it out myself. So I got 0.906. That is what I got. So which tally with what our calculator gave us as R square. See, calculator gave us 0.9057. But if you do this thing mathematically very well, I repeat again, first of all, finish your all this thing here. Let me color it in yellow. Once you have gotten your answer here, that is when you now raise to power 2. Okay, that is, you do 1002 times 855 times 1 over 10 minus 94,999. Anything you get, raise it to power 2. Okay, then you come to the numerator. 1002 raised to power 2 first, multiply by 1 over 10, subtract from 165, then you do the same thing for this, then you subtract the two value. So by the time you divide the numerator by the denominator, you should get this for your R square. Any question on R square, please, before I move on to the next one? Hello, any questions on how I got the R square before we move on? Yeah, Alpha.
I just want to
Yes,
add
please.
something. I want to add something.
Go ahead, bros.
Quickly,
Go ahead.
please.
You are one
Yes,
of
please.
the you are one of the experts we have here.
Please, can you go to the formula? our B2 formula.
This is our V2 formula. N summation xy, summation x, summation y, right? Oh yeah,
Yes.
go ahead.
So this B2 formula, we can actually easily do our R squared from it, so that you will not bother to, I don't know, to cram a whole lot of things and then start forgetting formulas. The only thing you just need to introduce in this B2 formula is a root on the denominator. Then you multiply by n summation y squared minus summation minus into brackets summation y squared. So you repeat this same thing that is in the denominator for x, but it will now be for y.
Try that? Can we quickly try that?
It's the same thing.
It is the same. If you look at this, if you look at this formula, you look at this denominator. Let me put it in yellow. Look at this denominator. Compare with this. They're almost the same thing, right?
They are the same, yeah.
Look at it.
They are the same.
They're almost the same thing. It's just this n that turned to 1 over n here, and you square everything. You just turn this n, you just make it 1 over n, and you square everything. They are the same. Just this n comes here 1 over n, then you square everything. They are the same. They're almost the same thing. So I did a lot of research this afternoon on ChatGPT before I could be able to get this formula, because I was actually working towards this 9.06. The calculator cannot be wrong, right? Okay, yes. So yeah, it can be wrong. All right, so let's move on to the next one. The next one is the standard error. But I don't know whether it teaches this standard error of B squared, B2. Okay, so see, we have done R square done. So whether we're going to cram or I don't know,
can we try?
Because I'm also watching for time too. I need to end this class. I still have theory to discuss. Which one do you want us to try? Yeah, say it fast.
Try that formula suggestion Emmanuel was talking about. If it will work, because this is your formula.
This one is too long, Abby.
It seems so.
Iman, do you want to give us the formula fast? Let's. So
yes, sure. Yes. Yes.
The formula is.
Give
me.
Can write this. Let me call it. N summation xy. N summation xy.
Summation xy. Okay.
Minus summation x summation y.
Okay.
Summation y. Divided by
what?
Root.
Okay.
So there will be a root on the denominator. Roots.
No. Okay. Root, Abby.
Yes, root. Square root. You put that square root sign.
Okay. Call the figure for me. I will put it. I will draw it last. Yeah, give me. Call it.
N summation x squared.
N summation x raised to power 2, Abby.
X squared. Yes. N summation x raised to power 2. Minus into bracket summation x squared.
Wait. Summation x squared raised to power 2.
X squared, yes.
Okay. What else? Okay.
Minus into bracket summation x squared. Into bracket summation x squared.
Like this, Abby?
Yes.
Anything else?
X squared. Yes.
Anything else?
Times. Yes, times. After closing the bracket, then you do times.
Just
times
continue.
N summation. N summation.
Emmanuel.
Y, Abby?
Yeah?
Emmanuel.
Y squared, yes, exactly.
Emmanuel.
Boss.
Is this square inside the bracket or outside the bracket?
It's like this, exactly like this. The first square is outside like this. Then the second one is in. It's outside. It's outside. It's outside.
It's
summation
now.
x. Summation x squared, like this B2 on top.
Exactly
like this B2 on top. I didn't even
see. If not, I need get answer. I need get answer.
Oh yeah,
Governor, you don't cram formula.
Let you copy the formula of the B2 down. Then you now add the
then
y.
The next one is y.
I think that one is better.
Yes, the second one is Y.
So which one is different? These two, my own and this one too are the same now. What is the difference?
It's just that this one will be a lot easier to memorize because there is already a B2.
Okay,
exactly.
So guys,
but
let me just put
square
it in green for you.
The square is outside.
Two of them, I'll put that. Two of them are not easy.
Let me introduce the third one.
No.
Let me introduce the third one. This one is better.
This one is easy because it's almost like the B square.
Can you hear me?
Okay, choose your poison better. Choose your poison. Choose the better poison. Both of them are poison.
I would rather choose this one.
Hello?
Okay. Which other formula again do we have? Our time will mean law. My time is going.
Wait, we're not done. No, this Y, the last
this
Y square should be outside.
You are putting that square inside, though.
Be outside. It's summation Y.
Don't put them. I don't put them. I don't put them.
And whatever you get,
are we done?
You've not introduced the roots. The roots in the denominator.
My own, the first formula is still okay, guys. Why are we troubling ourselves now?
Hello. Can you hear me?
Yeah.
It's because you have memorized it.
Oh yeah, choose your poison better. Choose a better poison out of the two.
No. The root is on my own.
Casey, if you look at the B square, the only two things you are introducing is the square root. Then everything you put in that denominator, you just multiply, change it to Y, and you are home and dry.
Oh yeah, choose your poison. Choose a better poison. K, you want to give us another one? K, yeah, Joe. Time will low. My time is. I've not started anything. I need to do standard.
I was going to adopt the one that the man has in his notes. I think is very straightforward. R square is equal to summation. R square is equal to summation x cap minus x bar square divided by summation y minus y bar squared. So that formula, what we need is
R square is equal to what? Summation
y cap.
Summation y cap
minus y bar square.
You know y cap minus y bar, everything square. Abi?
Yes, divided by summation y minus
wait. Why to be wearing bar and cap now? Wala. Just like right. Let me wear the cap and bar first of all. I've not done anything now, and time is rushing. Okay, y bar and y cap, Abi. Okay, then I will now divide it by what?
Y cap. So why are you in a rush?
Y cap, y bar.
See, me, I don't get work tomorrow. I can sleep by 4 a.m. Now, those way to go work.
We are here, so there's no need to rush. Let's get it right.
Thank you.
Y cap, y bar.
In the second one, this one.
The first one is cap. The second one is niba.
It will be wearing this cap and bar. This one is cap, and this one is bar. Abi?
Yeah.
Next, what next? Then the other one called
summation y minus y bar. Then square also.
Y minus. Now I try to use this formula. This y minus y bar is giving me 0. Should be y bar is your mean of y, Abi. I'm having 0, so I'm unable to solve it with this formula. That is the problem, because in the afternoon I tried this formula too. Y minus y.
Square is there.
I know what I'm saying. So this one give me 0. So that is the problem I had. That was why I had to jettison this formula and went to internet to look for formula. This formula gave me 0 for y minus y this thing, because it's saying I got 0. But when I subtract all the figure, it gave me 0. So I don't know. This formula, I'm still doubting it, whether it is correct or not. So the only one that gave me what I'm looking for is this one.
Hello.
Okay, can I continue to? Yes, sir.
Hello.
Yeah. Speak.
Hello.
Speak.
Sorry. Another one. When I did my. Hello, can you hear me?
Yes.
Hello, can you hear me? when I did my own, I used the formula that said that 1 minus RS divided by TSS. And when we are getting our RSS, that mean square that we just square the zero, that's y minus y bar. We just square it, that figure that we got. And in order to get our TSS, we will say that is y minus y bar and square it. The sum of y minus y bar and square it. That's how I got the TSS. And I got the same answer. I got 0.907.
0. Okay, so there are many ways to help. So 907. So we should choose. Let's choose our poison wisely. We choose the one that we prefer. Okay, thank you. Please, you can mute now. You can mute now. Let's move on. So I want to do now. The next requirement is we have to do standard error of B1, standard error of B2. But it is always better. You have to start with B2 first because you need your standard error of B2 in the formula for standard error of B1. I can even give you these two formulas now. Maybe I will let us try it on our own so I can move on to other thing. Standard error of B2. You have to do B2 first because you need this B2 for your B1. So standard error of B2 is equal to definitely I have to just draw it out. So this is the formula for this. Standard error of B2 is equal to square root of your variance square. This is your variance. Oh, what's it? Variance square like this divided by summation x square. Summation x square minus summation x square divided by n. So this is the formula for standard error of B1. However, this variance has its own formula. This variance square is equal to summation y minus y cap. I think we have this already. Y minus y cap. Y minus y cap square divided by n minus 2. So the first thing you do now, you first of all calculate this variance. When you calculate this variance, then you slot it to this formula to get your standard error of B2. Now, let me give you the formula for standard error of B1. So let's do the standard error of B1 to the formula for standard error of B1. So for standard error of B1 is equal to the standard error of B2, standard error of B2. So let me also write it, it's better. This is equal to SE, standard error of beta 2. Beta 2, the one we got above, standard error of beta 2, multiplied by multiply it by this root of summation x square. I don't know if this man taught us all this in the class. Divided by n, that's all. So that is all you need for this error, standard error of B1 and standard error of B2. That's the formula for this. So if you want to calculate standard error of B2, the first thing you need to calculate is this variance. I think we've done y minus, have we done y minus y cap? Let me see. Have we done y minus y cap already? Y minus y cap
Yes,
square.
it was the first thing that we did now.
Where is
not
it?
just square it up on the table.
This one, Abi?
Y minus y cap. So we'll just square this. Yes, the
we
last
will
column.
we will square we will square each of these figure, Abi?
Yes.
We will square each of these figures. So this is what we'll do. Start.
So Kazim,
each of these now we need to square it. So let me square them now. Oh, this is it here. This one. Oh, where is my rest of power sign? Oh, I'm looking for by raised to power 2, just like this.
Cousin.
Raised to
yeah.
Please, I'm with. Good evening. Yeah.
I'm sorry to bring you back. That our half square. I think we can just use summation y cap minus y bar into bracket square all over summation. The one that was in our note, TSS over TSS. It also gave me 0.903 as 2A0 as said.
So I think you can you can share the solution on the platform. So let's see it, because I only solved the one that I got the exact answer for. So maybe I didn't know how to apply this formula properly. Oh my God. Okay. My keyboard is not giving me what I want. So let me just do this. Okay. So do this.
Raised to power, just use that distance sign.
I'm done
use
already.
That
I'm done.
greater than above. Okay.
No, I've done it already. So this is it.
All right.
So this is it. This is your y minus y by square. Y minus y by square. This is it.
Yes, correct.
So you've done it, Abby. So
yes.
This one. Yeah. Okay. I think it's just like this, Abby. So the total is 140, Abby. So I'm calculating this variance first. So I got 140 here. So it will be 140. 140 divided by n. Our n is, you all know that our n is 10, Abby. That's 10 divided by 2. 10 minus 2, sorry, that's 8. So what is the answer? 140 divided by 8. What's our answer, please? What is our answer? Oh, that's our variance. 140 divided by 8. What is our answer? Variance square is what?
17.51.
17.51. So we can now apply this formula itself, this SEB2 formula, which is your root of variance 70.51 divided by summation x square. So where is our x square already? Our x square is this 165,024 summation x square 165,024 165,024, then minus summation minus same thing minus summation x itself. No, this x is in brackets. So sorry, the x is brackets, not the same. Let me do it properly. This x square is in bracket like this. There is a difference between x square and summation x raised to power 2. So summation x itself is how much? Summation x is 1002. So we have 1002 square raised to power 2. 1002 raised to power 2. 1002 raised to power 2 divided by what? N, which is 10. Okay, let me bring everything down. Divided by n, which is 10. So this divided by 10. So first of all, you need to do 1002 raised to power 2 divided by 10. Then you now minus it from 165. Then you divide it with this. So when you find everything, your final answer, because of time, let me just give you the answer. Your final answer should be about 0.16. That's what I got when I solved it. 0.016. Ima, does that align with what you got?
It is
Ima,
correct.
yes. Yes,
It is correct.
0.0164.
Thank God. Yeah. So let's do for standard error being 1. So guys, whether you have to cram all these things, I don't know how you're going to do it. So, but
Kazim,
that man was so sure of it. So yeah.
Sorry, I just wanted to add something real quick. So there is a reason for this n-2 in that. Can you go up a little bit?
Yeah.
Yes, there's a reason for this n-2 in this sigma square. The reason why 2 is like a constant that we are minusing from is because we are considering one explanatory variable and one dependent variable. So they are just two variables. It's a simple linear regression. So there are two variables, x and y. In a situation where we're considering it under a multiple linear regression, where we have two explanatory variables, where we can have, say, B1 and B2, and we also have we have X1 and X2. So that one in that case it will be n-3. Yes. So I just wanted to add that.
So yeah, thanks. So for SEB2, we have summation x squared. So that summation x squared, I think we use the same thing here. Is this 165,024 raised to power 2 summation x squared raised to power 2. This raised to power 2. So divided by n. You divide it by n. N is 10. So then you bring the root. You look for the root of this. Draw the root. So if you solve this thing properly, I think you should get, I think I got 2.015 something. I mean, I've got 2.05 something. So approximately it will be about 2.06 or thereabouts. This will be your answer for this. Okay? This will be your answer for SEB1. Okay? Then I think that's yes, sir. Yes.
Your SEB2 is can you go
standard
there,
error. Standard error beta 2. That's 0.016. This is it.
Exactly. But if you look at what you put in that SEB1, you put 0.16.
Oh, sorry. 0 point is a mistake. It should be 0. Yeah, this is it. 0.016. Yeah, it's a mistake. Okay. Because I've actually done it. For me to arrive at this answer, I've done it. I did everything in the afternoon. Even though ChatGPT was helping me out. Now I need to go and cram everything now. So this is what we have here. So lastly, now if you look at this question now, we have derived B1, B2, R square, SEB1, SEB2, and standard deviation U square. We have done all this now. We have completed A, we have completed B. Now let's look at B now. Comment on the significance of B2 using the criterion of B2 divided by standard error of B2. This is very simple. So what you would do here is that your beta 2, the actual figure you have for beta 2, you divide it by the standard error of beta 2. Okay? And they gave you a 2 that if the value is less than 2, it has a meaning. If it's greater than 2, it has a meaning. So in this case now, so we just do beta. So this B is very, very straightforward. They've given us the formula itself, so we don't need to do anything. So it's going to be your beta 2. That's your beta 2 divided by your beta 2 divided by, as per what they gave us, so standard error of B2. So that's what they say we should do here. So if you check, they have given us the formula already. Okay, they've given us the formula already. So what's our beta 2? We got our beta 2 this is our beta 2. Okay, beta 2 is this. Then what is standard error of B2? This. So you divide it by this. So what is the answer, please? What's the answer? If you divide it, what is the answer? So when I did my own, I got 9. I got 9. Okay. So what the implication is that your beta 2 itself is very significant in this model. That is the implication, that your beta 2 figure is very significant because it is higher than, what is it called? It is higher than the 2 that was given to you as a basis. So that shows that beta 2 is very significant. So that's how. So To the best of my knowledge, we've been able to solve this question, and I want to believe that these questions we've solved it correctly. All right, it's just like a small poison, but very difficult taste. So we all know what we need to do now. Basically, we need to cram R square formula. We need to cram SEB1 formula. We need to cram SEB2 formula. I think that's just what we need to cram. Okay, so it is 10 o'clock now. I don't know, and I've not even done what I'm supposed to do. So what should we do? What should we do? What should we do now? It's 10 o'clock already. Okay, so maybe I should just take 10, 15 minutes to run through some things fast. In 10, 15 minutes, then I will allow the next person to quickly come in. Okay? All right, so these questions that we've solved now, I would like you guys to please practice it and just attempt it as many time as possible, and you move on from there. So, okay, what I wanted to discuss was the theory. Is this still necessary? Maybe I should just let it. So you guys, please try and read. I wanted to discuss the theory with us, but because of time, it's already past 10. So what you need to know on this theory is know the definition of econometrics is very, very important. Note the function of econometrics. The three functions is very, very important. There are just three functions. Number one is to test the theory laid out by the converted econometricians. The second one is to estimate the variables, and the third one is to predict. I think the major function of econometrics is for prediction, to predict the future occurrence. Then you should also understand where you need econometrics when it comes to financial econometrics, what you can use econometrics to do. You need to understand that, e.g., testing whether your financial markets are weak or efficient, testing your CAPIM for forecasting of bond pricing. So those things, know at least 5 of this. Then your data structure too is very important. Know what is time series. Time series is when you collect data over time. Maybe you collect 10 years voting result or something. When you collect the same data over time, that is time series. A particular set of data is collected over a period of time. That is time series, right? Then cross-sectional is basically a single period of time. When you collect a data from different observation over a period of time. E.g., for one state, you want to know their GDP, you want to know their population, you want to know the number of males, you want to know the number of females for just a particular time. That's cross-sectional. You are more focused. Cross-sectional is more in depth, right? Basically for a particular period of time. E.g., for an individual, they want to know your age, your name, your marital status, basically for a particular period. That is cross-sectional. It is more in-depth than time series. Time series just focus on one thing for a long time. E.g., what is the GDP for 10 years? That is time series. But cross-sectional, pick a particular sample and drill it down, okay, for a period of time. That's time series. Then knows what is known as a pool data. So this pool data basically is when you combine both your time series and cross-sectional together. It's a combination of both your cross-sectional and time series. That's what we call pool. So please note that I just feel I should let you guys know all those things, right? So now these 8 steps in carrying out studies too. In fact, I had to drill myself this afternoon so I can be able to call those 8 steps without looking at books. The first one is your statement of hypothesis. That is, what is the problem that you want to solve? You need to know that which problem are you trying to solve with econometrics? That statement of hypothesis, you need to stop. You need to understand that. Then, after you have been able to define the problem you want to solve, the next thing is your mathematical model. Mathematical model is when you try to express your model in form of when you try to express your problem in form of a model. That is mathematical model. E.g., you can see y is equal to function of b beta 1 beta 2 x. So you can see this is a mathematical model. Why is it a mathematical model? Because it does not include your u. But the moment it includes econometrics model. So if you look at step 3 now, is you now derive your econometrics model. So what are you doing on the econometrics model? Whatever you have gotten here under mathematical model, just add U to it. That makes it econometric model. So the same thing we got under a mathematical, we just add U. It is this U that makes a model, an econometric model. So the first step is your hypothesis. Second step is your mathematical model. Third step is your econometrics model. And the fourth step is you obtain data series through a cross-sectional, through a pool data or panel, whichever way. So once you have been able to obtain your data, then you now estimate your parameters. Now, let me explain the difference between, Funmi, please get ready. You'll be coming on shortly. I'm just quickly running through this with them. Please get ready. So let me explain the difference between a for us. So if you have this as your econometrics, y b1 plus b2 x 1 plus u. So this b1 and b2, they are known as parameters. Okay, they are known as what? Parameters. Why this your x and y? They are variables. X and y are variables. Then y is your dependent variable, x is your independent variable. That this u is your stochastics or your random or error terms. But note that this beta 1 and beta 2, they are known as what? Parameters. Y and x are your variables. So note what they are talking about. So you estimation of the parameters of the econometrics model. That is, when you are estimating parameter, you are estimating your beta 1 and beta 2. Then once you have been able to do that, you test your hypothesis. So your hypothesis is just to get whether something is true or false. Your hypothesis cannot give you true answer. Is either it gives you true or false. So once you have been able to test your hypothesis, then you can now predict your result. Once you predict your result, then you can use your model for control or future planning. Those are the 8 steps involved under econometrics. So let me try and read them again without looking at the books. The first steps is state your hypothesis. That is, what problem do you want to solve? Then the second steps is you state your mathematical model. That is your AY without U. Then the third steps is your econometrics model. Then the fourth steps is your obtaining your data. After you've obtained data, the fifth step is to test your parameters. Then after you have tested your parameter, number 6 is your hypothesis. Then number 7 is you forecast or predict. And the final one is you use your model for control and planning. So I think that is where my power carry. So let me now hand over to the experts to take over from here with OL. So I believe I've been able to cover this, even though it was very fast. I believe I've been able to cover it briefly.
Please still share your screen.
The same material, B?
Yes, just share your screen, please.
Yeah, I believe I've been able to cover this part. So now let's move on to OLX assumption and that class test itself. Let's move on to that right now. So yeah, my screen is up. Please carry on. Just tell me where you want me to go.
Okay, so can you move to page 23? That simple linear regression model.
Page 23. Okay. Thank you.
Okay, so good evening, everybody. Anyway, we'll be doing this together. I'm not an expert, though. We've actually been learning this together. So I'll just try and revise the assumption of OLS with us again, and we'll try and solve what was the test that was given to us in class. At least using the person that scored the highest mark scripts as a guide, as a marking guide. So that we know
can we share that what's the script here?
We are going to share it. We are still coming to that. So, but I'm trying to start with this. Do you understand? So I will still. Okay, you've off your data.
Oh, we can hear you. We can hear you. Continue. We can hear you.
Can you guys hear me?
Yes.
Okay, so I'm going to start with simple linear regression. We all know what simple linear regression is, right? We all know that simple linear regression consists of two variables. We have the independent variables and we have the dependent variables. So in simple linear regression, we only have one we only have one independent variable. That means the effect of the independent we are testing for the effect of the independent variable on the dependent variable. Just we are just using one variable under simple linear regression, and we are familiar with our PRF and our we are all familiar with our PRF and our SRF. We all know that for PRF we use our SRF to estimate the value of our P. Is like we are using our SRF to derive inference for our PRF. We all know that PRF is just the normal equation, normal simple linear regression equation. That's y is equal to b1 plus b2 x1 plus ui. Why SRF is the one that has cap, is the one that has the estimate, which is y is equal to b1 cap plus b2 x cap plus ui. So, and we have two estimator that we use for this. So which is OLS. OLS is one of it. And sorry, just give me a minute though. So we use OLS technique to to find our estimates. And I'll be moving down to the properties of OLS. So what are the properties of OLS? We are part of this least square estimator, and the major goal of this estimator is just to minimize the variance of our variable, to minimize it to as small as possible. Like we are trying to minimize the variance as low as possible. So, and we have the properties of OLS is linear, is unbiased, and it has a minimum variance. And for the property of linearity, it is linear. It is linear, that is a linear function of a random variable, such as the dependent variable, while in the regression model are linear function. The least square estimates b1 cap and b2 cap are linear function of the observed sample values yi. So, and then we have for unbiased, its average or expected value is equal to the true value. That means the expected value of b1 cap, page 34, Kazim. This is not page 34. This is properties of regression line. Properties of OLS itself is on page 34. So let me continue. The properties of unbiasedness, which means that the expected value for B1 cap is equal to our B1 itself, and the expected value of our B2 cap is our B2 itself. So the meaning of this property is that the estimate converge to the true value of the parameters as we increase the number of sample. If we take a possible sample of size n of the observation and compute each of the sample, the estimates we will obtain a large number of such estimates, which mean will be equal to the parameters of the relationship. So let me move down to minimum variance. So for minimum variance, it has minimum variance in the class of all such linear unbiased estimator. An unbiased estimator with the least variance is known as efficient estimator. OLS is efficient because it ensures that the unbiased estimator has a least variance. So the major goal is to reduce our variance to as small as possible. So this property is main reason for the popularity of OLS. That means the property of minimum variance made OLS popular. So it has a smaller variance. OLS estimates a linear function such that it will have minimum variance. So let me move back to the assumption of OLS itself. Can I move on? Can I move on? Yes, please.
Yeah.
Okay. So let me move on. We have assumption of OLS. We all know that we have two two categories for OLS assumption. We have stochastic assumptions and we have other assumptions. So for the stochastic assumptions, we have like 6 assumptions under the stochastic assumptions, while the other assumptions consist of 4 assumptions. So for our number 1 assumption, our error term is a random real variable. We all know what a random variable is. We can say anything is random, right? It means that thing can take any value. That thing can take up anything. So error time is a random real variable. It shows that the value which our error may assume in any one period depends on chance. It may be positive, it may be negative, or it may be 0. That means our error term is a random real variable because it can take any number, either positive, negative, or 0. So our assumption 1 for our OLS means our error term is a random real variable. For instance, maybe we were given a question and they said that our sales is a random our sales can take up any variable. Our sales can take up either our F price, our O price, just like our test question, our O price and lateness. It shows that our sales can assume any random real variable. Our sales can be a function of any random variable, either positive, negative, or 0 value. So that is for assumption 1. Can I move on to assumption 2? Can I move on to assumption 2?
Yes, please.
Yes, please.
Okay, thank you. So let's move on to assumption 2. We have 0 mean value of disturbance for assumption 2. We have 0 mean value of disturbance. So for 0 mean value of disturbance, it means that the expected value of our random disturbance term UI is 0. the expected value of our random disturbance terms ui is 0. It means that the expected value of y of our random variable, the expected value of our random variable, given the value of our x, is 0. The summation of our random variable, Kazim was plotting our regression line earlier, and we all know that the summation of our u after we've inputted x into those equation is 0, right? And we all know the value of our u. Our u is what's our u? What's the equation for our u cap? Our u cap is y minus y cap, right? So, and our y cap is equal to b1 plus b2x. So in short, our u is equal to y minus that particular equation, y minus y cap. So, and we is tested. We all know that the summation of all those values, given the value of x, is 0. So we should just note that, and the equation is our e into brackets ui slash xi is equal to 0. That is the equation. So the equation is on we can see it 6.1. That is the equation for our expected value of u given the value of x is equal to 0. So let's move on to equation assumption 3. So we for assumption 1, let me do a recap. Our error term is a random real variable. For assumption 2, zero mean value of disturbance, which means the expected value of our error term, which is also known as disturbance, is equal to 0. The expected value of our u given the value of x is equal to 0. So now let's move down to homoscedasticity or equal variance of error term. Our error term is u. Let's note that our disturbance is u. So for homoscedasticity, you all know what homo is. Homo means equal. Skedasticity means spread. Equal spread. And we have heteroskedasticity as well, which means unequal. Hetero means unequal, while skedasticity means spread. So for this assumption 2, it said that our error term must have equal variance. For our error term. We all know what variance is. I think the last time we discussed this assumption, someone said deviation from the standard. So that means the deviation for the standard for our error term must be equal. So let me see what we have here. So he said that given the value of x, the variance of our error term is the same for all observation. Given the value of our x, the variance of our error term is equal for all observation. That means our variance into brackets ui slash xi is equal to sigma square. Variance into brackets ui slash xi is equal to sigma square. And this can also be written. We can see the second the 6.15. It also says that expected value e into brackets ui square slash xi is equal to our sigma square. It's the same thing as variance into brackets ui slash xi is equal to sigma square. It's also the same thing as e into brackets ui square slash xi is equal to 0. So for OLS, we should all know that they want to reduce everything. Can I continue?
Sorry, what page? What page are we, please? I'm trying to look for it.
Page
what page?
32. Page
32. Thank you.
Yes. So, where did I stop? I want to say something. So for OLS, we should all know that we are trying to reduce anything that is square to a minimum, let's just say a minimum value. We are trying to reduce them to a minimum variance. We are trying to reduce the effect. So let's move on. So for heteroscedasticity, it says that the variance of all observation given the value of S is not equal, is not identical for heteroscedasticity. So when we see something that is not identical, when they are talking about variance is not identical, it means that we are talking about heteroscedasticity. And as I said earlier, our heteroscedasticity means unequal spread, unequal variance. So, and we all know the formula. We can see the difference looking at equation 6.16 and equation 6.15. There is actually a difference between the two equations. Please, can someone note the difference for me? Please, can someone note the difference for me? Mr. Oladiran, can you note the difference for me between equation 6.16 and equation 6.15? Okay, so since anybody does not want to
The
answer,
difference is the I that is under the variance, that is beside the variance, brother.
Okay, that is beside the variance. So, as Emmanuel has said, for heteroscedasticity, we have the variance into brackets ui slash xi close brackets is equal to sigma square I. Why for homoscedasticity, we have it as variance into brackets ui slash si is equal to sigma square without I. So let us all note the difference between these two equations. So let me move to assumption 4. Let me move down to assumption 4. Can I move on? Do anybody have any question or any addition before I move on? Please, though, this is a group interaction. Let's do this together. So I may have omitted something. So any addition or comment or anything will be appreciated. So let's move down to assumption 4. So for assumption 4, our error term has a normal distribution. Our error term has a normal distribution. It shows that the distribution for an error term is normal. So what we have there is that it have a bell-shaped symmetric distribution about their zero mean. There are both assumptions about the behavior of values of u may be summarized in the expression. We can see the expression for our u as a normal distribution, and it says that, okay, so now let me explain this particular assumption 4. What it means is that this assumption 4 is combining assumption 2 and assumption 3. In fact, it's combining the whole 3 assumptions. For assumption 2, we know that a random disturbance term u, the expected value of a random disturbance term u is 0. We all know that u can take up any value, and we all know that the variance for an error term is constant for homoscedasticity. So it is assumed that the variance for an error term must be constant. So when we move down to this assumption 4, is combining these 3 assumptions. We know that u normally it has a random is a random real variable. So So for normal distribution, it has both our both assumption 2 and assumption 3, and we said for you to be normally distributed, it must have zero mean and a constant variance. For you to be normally distributed, it must have zero mean and a constant variance. We can see this particular equation, which is u, I don't know that line, but one slopey stylish line like that, our n into bracket 0 comma sigma square u. So that is for our assumption 4. I want to move fast so that we can reverse that class assignment to that class test together. So let me move on to assumption 5. Please, can I have assumption 5 on screen? So for assumption 5, we know that no autocorrelation between disturbance. No autocorrelation between disturbance. It means that two errors, they must not explain each other. Two errors must not be correlated. And when we talk about correlation, please, can someone tell me the meaning of correlation? Like in a layman word or something. What does correlation means?
Moving together.
When something is moving together. But what assumption 5 is saying is that they must not be related. They must not move together. It's just like let me use the example of when two people want to get married. There'll be some people will do some their parents may do some findings is that, oh, we are not related by blood. Do you get, Yoruba, there are some countries that some people marry their cousin or they marry themselves. But for especially Yoruba culture that I'm very much aware that the two people must not be siblings, they must not be related by blood. We should not be able to explain their family. We can do some findings about their family, but not knowing them. So that is an example. I'm not saying it's a perfect example, but at least the error of yesterday must not be able to explain the error of today. The error of yesterday must not be able to explain the error of today. So if the error of yesterday can explain the error of today, I think the man said it will lead to a simultaneous equation. So, but let me move on. So it's just that giving any two value of si and sj, the correlation between any two ui, that means ui error of, let me just make it error of yesterday, and uj, which is error of today, is 0. Symbolically, we have said that the covariance into brackets ui comma uj slash xi comma sj is equal to 0. So in other words, the disturbance ui and uj are uncorrelated or equal to 0. When something is equal to 0, it shows that they are not related at all. It's just like you saying ui plus uj is equal to 0. Ui is equal to minus uj. So it still shows that they are not equal. They are not the same thing. So now that part, there is number 5 of that test that we were given. The man said that yesterday error can explain today's error. It shows that they are related. Like they are related. They are moving together because it can explain. But for OLS, it is assumed that our error term, the error of yesterday, whatsoever error we get yesterday, must not be able to explain today. Let's just say this is my reason for coming late to work today. Tomorrow I'm giving the same reason. The next day I'm giving the same reason. Like, sorry I used Yoruba, but is already looking alike. But what my assumption 5 is saying is that for my excuse to be genuine, my lateness yesterday, or why I came to work yesterday, must not be must not be equal to why I came late to work today. Do you understand? Maybe today I said, it's traffic. Oh, the next day I said it's traffic. The third day I said it's traffic. My boss will be tired of me and said, okay, it's traffic. Why are you not leaving your house late? Why are you giving these excuses? Why are you consistent with this? So, and again, what I understand about this assumption 5 is that it's saying is just saying that, okay, I'm not saying that is right, but there must be dynamic. We don't want a usual thing. We don't want something that is static. We don't want what is happening yesterday. We want a different event yesterday, and we want another event today. So yesterday error must not be able to explain today's error. Do you understand? So let's move on to assumption 6. Please, do we all understand? Can I move on?
Yeah, we are getting it.
Yes.
Okay, so by 10:41, I will move down to the assignment, to the test. I think with some of my explanation, we should be able to answer the test without even without even without even looking at our notes, at least with these few explanations. So let me move down to assumption 6. Assumption 6 says that the disturbance term is not correlated with the explanatory variable. That is, our U is independent of explanatory variable, which shows that the covariance UI, XI is equal to 0. I'll still come back to that. Assumption 6 states that the disturbance U and explanatory variable UX are uncorrelated, and the rationale for this assumption is as follows. When we express PRF, by now I think we should all be familiar with PRF equation. Our Y is equal to B1X, B1, plus B1X plus U. That is our PRF equation. We can refer back to this particular equation in our notes, which is 5.010. We assume that X and U, which may represent the influence of all omitted variable, have separate influence on Y. We all know why we have a stochastic element in our equation, a stochastic variable, which is the same thing as our error term or disturbance. It represents all the influence of all other omitted variable. We are all familiar with our consumption function. We know that our C is equal to A plus BY. It doesn't mean that Y is the only determinant for our consumption. I want this particular car. It will affect my consumption. So it can be price of related goods, it can be my taste and fashion, it can be so many things. So I'm representing all other variables with U, with error term. So what is now saying is that all those other factors must not be the same thing as our error, as our independent variable. Our U must not be the same thing as our income. We must be able to test the influence of each variable on our dependent variable. We must be able to test the influence of our U on our dependent variable. We must be able to test the influence of our Y on our independent variable. Without, the two of them must not have any relationship. For instance, the man used a person that has like 20 girlfriends in class. So this particular girlfriend must be able to test their influence on the person that is having the, okay, let's say now, I don't want to use I don't want to use anybody's name in class. Let's say OJ have 20 girlfriends. So now the 20 girlfriend, let me just mention 3. We have Lola, Titi, Shokpe. So we must be able to test the influence of Shokpe on OJ. We must be able to test the influence of Lola on OJ. So these two are not, they must not be related. So it's now saying that the expected value of our U and our X is equal to 0, which is the same thing as the covariance into brackets U, xi is equal to 0. If we look at this assumption 6 equation and our assumption 2 equation, we will see that the major difference between their equation is that for assumption 6, it is ui, xi, while for assumption 2, it is ui slash xi. So that is the major difference. So now moving forward, there's a particular question that says that what is the resultant effect when we have a positive and a negative correlation? So if we look at if X and U are positively correlated, our X increases when U increases. That means if they are positively correlated, it means that once X increase, our U will also we increase. And then if it is negatively correlated, it means our S decrease, when our U decrease, and when our U decrease, our S increase, and when our U decrease, okay, sorry, let me come again. When our X increase, our U decrease, and when it decreases, our U also increase. In either case, it is difficult to isolate the influence of S and U on Y. So we can't isolate the influence of U on and the influence of X and U on Y when they are positively correlated or they are negatively correlated. So just know that for 0 covariance between U and X, sorry, this is already 1041. I'm going to rush through the other 4. So when our U and X must not be correlated, we must be able to test the influence of the two of them on our dependent variable. So let's move down to other assumptions of OLS. So those are the 6 stochastic assumptions of OLS. So now we are moving down to the other assumptions of OLS. Please, can I have assumptions 7? So for assumption 7, the man told us that assumption 7 is not really, really important. So I'm going to read assumption 7 from my notes. It says that the explanatory variable are measured without error. Mr. Kazim, please, can you hear me scroll up? Please, can you guys hear me?
Yes, we
Can
can
you
hear
guys
you.
hear me?
We can hear you.
I can hear you.
Okay. I think
Yes, we
Kazim
can hear
is
you.
not. Okay. So let's move down to assumption 7. The explanatory variables are measured without error. The explanatory variable are measured without error. You absorb the influence of the omitted variable and possibly errors of the measurement of y. That is, we will assume that the regressor are error free, while the y values may or may not include errors of the measurement. So let me just move down to assumption 8. So for assumption 8, there is no perfect multicollinearity. There is no perfect multicollinearity. So I would like to read this for us. The explanatory variables are not perfectly linearly correlated. Okay, that is, there is no perfect linear relationship among the explanatory variable. if there is more than one explanatory variable in the relationship, it is assumed that they are not perfectly correlated with each other. Indeed, the regressors should not even be strongly correlated. They should not be highly multicollinear. So now we have two explanatory variables. What multicollinearity is telling us that we are assuming that these two explanatory variable, and we all know what is explanatory variable. Our explanatory variable is the same thing as our independent variable, and it is always given. It is what is used to predict the value of the dependent variable. So for explanatory variable, we all know that they must not be, like, they may be related, but they must not be perfectly related. It still boils down to, we want to try and test the influence of each of them on our dependent variable. So they must not be, some of them may have some similarities. Let's say, for instance, the test we were giving sales is equal to the function of our O price and our F price. Our F price and our O price, they are both price, abi, but for F price is the price at which they sell in gender supermarkets, while O price is the price at which they sells in what's this common place that they have their supermarkets everywhere. Please, can someone remind me the name of that store that they have their supermarkets everywhere now? So Bokumat. Thank you so much, Bokumat. So the O price in Bokumat, they may be related, but they must not be perfectly related. Let's say Jendot is selling Indomie for 100 naira. Boku marked. Boku is trying to win every consumers over. So, in every household, we should be able to mention that, the first thing that will come to our mind when we want to do our shopping should be Boku marked. So, is in like in Lagos now, you can virtually find Bokumans everywhere on street. And sorry, I'm just digressing. So the price of in Bokumat must they may be related. They are both prices of Indomie, but their prices should they must not be perfectly related. So that is what our perfect multicollinearity. There must not be perfect multicollinearity for assumption of OLS. For OLS to work very well, that is why we are making all these assumptions. So for OLS to work very well, there must not be a perfect relationship between our two linear two variables, two explanatory variables, or our explanatory variables. There must not be relationship, like, error term. The man always use when you have 20, or when you have five girlfriends and their behavior is alike. It shows that there is presence of multicollinearity. They are related, like their behaviors are related. It shows that there is presence of multicollinearity. But even if their behavior is related, if you cannot tell between their behaviors, you should be able to have a little difference. Let me say the behavior of Kafayat. Kafayat and Temi, they are very close. We all know they are very close. So for anybody that know Kafayat and Temi, anybody that see Kafayat, you will surely see Temi. Anywhere you see Kafayat, you will see Temi. So, like, Temi is calm. Kafayat too is calm, but when you move closer to Kafayat, you know that Kafayat is not that calm as Temi. I'm sorry to use these two people, but at least that's what comes to my head. So you know that Kafayat is not that calm than, like, it's not that calm. Temi is at least is more gentle than Kafayat. So that is their little deviation. They may behave the same way, but at least there should be a significance of something that can tell them apart. That is what multicollinearity is talking about. So then we move. I'll move down to the next assumption is the regression model is correctly specified. Like we must specify our regression model correctly. Under the 4 steps, the 8 steps of econometrics, we set specification of our model, specification of our mathematical model. So our models have to be specified correctly without any biasness. So and properties of OLS, unbiasedness is part of the properties of OLS. So then we move down to assumption 10. We can read more on this, it's self-explanatory. So we move down to assumption 10. The micro variables should be correctly aggregated. That means the summation, we should do a very a proper procedure when we are doing aggregation of our micro variables, just like when we are doing aggregation of our regression, when we wanted to solve for the for the values of our, when we want to look for the value of our estimate. When we want to look for the value of our estimate, we know that if we don't add correctly, or if we didn't do the correct calculations, we won't get the real answer. Or okay, like I think I was sharing one of my solution with someone, and I just did that solution. I did it very fast, and I got some funny answer. So I had to sit down calmly to do that solution all over again, so that I can get something that is right. So that is what assumption 10 is telling us. So I'll just run through on the test that we're giving. So please, Kazim, I'm so sorry that I'm stressing you. Can you share the solution? Before you share the solution, I would like us to do a run through on the test, like answering it ourselves without looking at anything, without looking at our book. So now for the test, we all have Kukwala and Ogechi as researchers. Were asked by the CEO of Christ Embassy Food Restaurants to develop an econometric model to analyze and forecast the sales of fried rice in the Faculty of Management Science. The researchers advocate using the following econometric model, which is sales is equal to beta 1 plus beta 2 F price plus beta 3 O price plus lateness. And we say it was recorded our sales, our SAL is sales, our F price is price of fried rice in FMS branch, and our O price is the price of other rice in FMS, not sold by Christ Embassy. FMS have 2 products, but Christ Embassy is not selling one of their products. We may have another, just like Indomie and Minimi Indomie and Indomie. We have one, they are both Indomie. So we have one store selling Minimi and we have the other one selling the real Indomie. So not sold by Christ Embassy Food Restaurants. And lateness is the error term, on the assumption that sellers always come late to sales center. Are you still with me? Are you guys hearing me? Are you guys hearing me? Yes. So now let's move on to number 1. With an assumption symbol, explain the sum of mean deviation. Explain what the sum of mean deviation will be if the researchers apply the criterion of minimizing to variables in the model. So what this particular question is saying that,
hi Funmi.
Yes, I'm
hello.
with you.
Sorry, I cannot see your screen again. I don't know if it's just me.
Okay. Kazim is resharing. Okay. Kazim is actually resharing. We stopped sharing initially, so he's resharing. So
All right.
He's trying to reshare this. So now, but Kazim, I don't want you to share this now. I just want us to call it randomly. So then you are going to reshare this. I don't know if so let's move on. So now, it's saying that can we all hear my our question 1 with an appropriate symbol? Explain the sum of mean deviation. What the sum of mean deviation will be if the researchers apply the criterion of minimizing to the variable in the model. So who can tell us what this as number 1 assumption is saying based on what I've explained earlier?
I think hello.
I
think it's zero mean disturbance.
Yes, zero mean disturbance. So let's move on to assumption. Let's move on to question 2. So with an so do we all hear him? He said zero mean of disturbance. And we all know what zero mean of disturbance is. So let's move on to question 2. With an appropriate econometric equation, differentiate between E into brackets lateness slash F price is equal to 0 and covariance lateness comma F price is equal to 0. So who can just tell us what it means in 2 seconds? Who can tell us what that means? Okay, we are going to move on now.
Funmi, sorry. The thing is, we cannot even see any question. So I don't know, but I'm speaking for myself. I can't see any question. So I can't really trail what the question is. I'm giving any answers.
I'm not projecting the question. I'm not. No, I don't have the question on my system. I only have the solution.
Okay.
We all have the question.
I'm so sorry. Let me read it out again. Let me read it. Emmanuel, just I will read it out again. With an appropriate econometric equation, differentiate between E into brackets lateness slash F price is equal to 0 and covariance into brackets lateness comma F price is equal to 0. Our lateness is our U, while our F price is our explanatory variable X. So who can tell me the 2 assumptions that is compounded in that particular question?
That's between assumption 2 and assumption 6. Assumption 2 is under zero mean disturbance of mu, which is the first one you said. Then for the second one is the zero covariance. So zero mean disturbance and zero covariance between mu and given the value of x.
So when we project when Kazim project the answers, yes, sir.
I just checked the question on the WhatsApp platform, so people can pick it up there so that they can relate it with the answer being projected.
Okay, sir. Thank you, sir. So let's move to number 3. So let's move to number 3. Okay, so I think Kazim has projected it, so we cannot see the question now. Thank you, Kazim. Thank you, Prof. Okay, so number 3, symbolically, explain what happened if F price is negatively or positively correlated with the lateness in the model. Please, who can explain that? I think we explained that in assumption 6. So who can explain when?
When you were talking about the relationship between U and X, if if there's a positive or negative relationship between the two, if X is if there's increase, if there's a positive relation between X and U, which means X increase positively, then the U2 will also increase. I think you explained that earlier on, right? Then if it's negative relationship between the two, X will increase while U will decrease.
Vice versa, yes. Vice versa. So let's move to assumption. Let's move to question number 4. Symbolically, define and explain the resultant effect if the conditional variance of lateness in the sales equation are not identical. So there is two things to be noted in that particular question. We have variance and we have not identical. So who can tell me what that means? Heteroskedasticity. And I want us to get familiar with the equation as well when we are reading or when we are revising our notes. So I'll move down to question 5. State the consequence if F price and O price. We have two explanatory variables now, F price and O price. We can see the equation. Sales is equal to B1 plus B2, F price plus B3, O price plus lateness. We have two. This is a multilinear what?
Multicollinearity.
Multilinear.
That's no multicollinearity.
No. I'm trying to say the name of this equation. Multiple regression. Multiple regression. Emma Binu, what is that family? So we have this O price and F price. And when we say O price and F price are correlated, it shows that these two particular explanatory variables, both of them are correlated, but we said that they must not be correlated, right? So and now they are correlated. So who can tell me what happened to that particular what are they talking about? What are they asking about?
There is no multicollinearity.
There is presence of multicollinearity. But assuming they are not correlated, assuming this F price and O price are not correlated, it shows that there is no multicollinearity. But they are correlated. So it shows that there is presence of multicollinearity. So now let's move on to question.
What are you still doing?
Let's move on to question 6. Outline the consequence if today's lateness in the sales model is correlated with yesterday lateness in the model. So who can tell me what this answer is? Today lateness in the sales model.
There's no correlation with disturbance.
No. No. That's not the answer.
Okay.
I think the answer is autocorrelation. That is
there is presence of autocorrelation, yes.
Because today lateness in the sales model is correlated with yesterday.
Yes, so it is autocorrelation. That means we have
autocorrelation.
Can I what?
Can you please explain more on that?
Okay. So now, in our class,
you want me
okay. So now this
so that it's no.
You can see the. Please, can you mute your mic so I can hear me? So now we can see this projection. So for autocorrelation, for assumption number 5, we says that there must not be autocorrelation among our disturbance, between our disturbance, given two values of x. That means yesterday lateness must not be the same thing as today's lateness. What is happening yesterday must not be the same thing as what is happening today. The effect yesterday must not be the same thing as the effect today. But what this particular question is saying is that what happened yesterday is explaining what happened today. So it shows that there is autocorrelation. Assuming what is happening yesterday is not what is it's not explaining what is happening today. It's not the same thing as what is happening today. It shows that there is no autocorrelation. But once it is the same thing, once two errors are explaining each other, it shows that there is presence of autocorrelation. But once two errors are not explaining each other, it shows that there is no autocorrelation. Do that explain your question?
Yes, thank you so much.
Yes. So now, Kazima projected the answer. So now for assumption 1, we can see the man's marking guide. So this person actually explain what zero mean value of disturbance is, and he also states the equation. So let's move to number 2. For number 2, the person states the two equations, like the two assumptions, and at the same time state the two equation. For E into bracket ui slash xi is equal to 0 is for zero mean of disturbance, while for E into bracket ui comma xi is equal to 0 is our zero covariance. So I've told you earlier that the difference between this, one has slash and the other one has comma. So let's note the difference. So then for number 3 question. So that was when we were talking about um positive and negative correlation, under our assumption 6. That particular, I think someone also explained it earlier. So it's showing that our u into brackets ui comma xi is not equal to 0. So he was able to differentiate between these two. I think we were able to differentiate between the two earlier. So let's just move down to number 4. So he talked about the heteroscedasticity. The situation, we know that when our variance is not identical, variance of all observation, when they are not identical, when the deviation from the standard, they are not identical, so we have our heteroscedasticity. But once they are identical, we have our homoscedasticity, which is assumption number 3. Our heteroscedasticity is actually violating assumption number 3. But when we have a question like this, or when we have a scenario like this, we know that we are talking about unequal spread, which is also the same thing as heteroscedasticity. And we can differentiate. Emmanuel differentiates between the two equations for us earlier. One has I. They are both the same equation, but the only difference is that one has I and the other did not have I. The I indicates that they are not identical. Assuming they are identical, it's supposed to be the same thing. So, and I can assume any number. We can have, given I is equal to 1, 2, 3, 4, 5, 6, 7, 8. So we all know that 1, 2, 3, 4, 5, 7, 8. Sorry. So our high can take that. So we have to apply. That means for all observation, their variance, they are not the same thing. Our high is not the same thing. So let's move down to number 5. Number 5. Number 5, sir. Hi, Kazim. Number 5. Hey. So for number 5, this is where I'm very interested, because this is where I got it. I don't know what I did here, Sha. So number 5, if the variables are correlated, as in the multi-regression model, this is the situation of multicollinearity. And the consequence, the variables will be explaining each other. And we all know that for multicollinearity to happen, the explanatory variable must not explain each other. They must not be able to explain each other, because you won't be able to differentiate between the effect they have on our dependent variable. And one variable will drive or influence the other. That means once the explanatory variable is explaining each other, they will have influence over each other. So we won't be able to detect the influence they have on our dependent variable. So for number 6, this is a situation of autocorrelation. We've explained what autocorrelation means. Autocorrelation means when two errors are explaining themselves. But for autocorrelation to happen, and for the assumption of OLS to be for OLS to be a good estimator, for it to be able to minimize our variance as small as possible, for it to provide unbiased judgment, and for we have the properties of linearity. So our two errors, when we have two errors, they must not be able to explain each other. They must not be able to explain one another. And we all know the 3 major properties of OLS: the properties of linearity, the properties of unbiasedness, and the properties of minimum variance, which is the most important out of the 3 OLS, 3 properties of OLS. Okay, do you have any question? Do you have any addition?
So
Any
I have a question.
subtraction?
I have a question,
Okay,
Funmi. Yeah, I
I'm
don't
with you, sir.
understand that. I don't understand that question 3. Can you explain it?
Question.
Can you explain it better? Yes.
Okay, question 3. It says that explain what happened if F price is negatively or positively correlated with lateness in the model. We should all know that once F price is negatively correlated with our lateness, and we all know what correlation means. They are related. So it's not saying if they are negatively correlated. What does it mean? That means in my own language, when something is negatively related, it shows that they have inverse relationship. It shows that once like now, we have C is equal to A plus BY, and we all know that when consumption increase, when our income increase by 1 naira, our marginal propensity to consume will increase by 45 kobo. I'm trying to use our example. We increase by 45 kobo. So now, assuming it is C is equal to A minus BY, you know that once our income increase by 1 naira, our consumption is going to reduce by 45 kobo. That's by the way. So it's now saying that in an equation, that when we have our explanatory variable is negatively correlated with our error term, it's showing that once the influence of our explanatory variable, once it increase, the influence of our explanatory variable on our dependent variable, once it increase, the influence of error term will also increase, and vice versa. So once it decrease as well, the influence of our error term will also decrease. But when it is positive, when it is negatively correlated, it shows that when the influence of one increases, the influence of the other one will decrease. And once the influence of the other one increase, the influence of the explanatory variable, which is X, will also decrease. Is it better now? Did I explain at least? Is it a bit better than before?
A little bit. So it's under what assumption now?
Assumption 6. Assumption 6.
Still under the
The
zero
second paragraph.
covariances. Okay.
Yes, it's under the zero covariances.
Okay.
All right.
Okay.
Thank you.
Okay. Thank you very much. Thank you so much. So let's move on to the last phase. Kay, are you ready? Kay, are you ready? Oh, Coyote is not sleeping now. Hello, Coyote. So while waiting for Coyote, we've covered this second part of tonight's class. So the next phase is for us to have an idea of multiple regression and interval estimation, this was the last topic the man took in the class, on his last day. Interval estimation, that was the last topic he took. Kayode, can you hear me? I hope this guy is not sleeping now. Hello, Kayode, unmute and speak. Oh. So we've done the first part, we've done the second part. The last part is multiple regression and interval estimation. Interval estimation was the last topic that it took us before we end the class. So Kayode, are you there?
Can you hear me?
Okay, thank God.
Can you hear
Okay,
me?
so you can just take over from now till 12 now. So just run us through, I can hear you, run us through multiple regression and interval estimation. So over to you. I will stop sharing now so that you can take over.
Okay, good evening. We've had so much, discussion so far. I'll just be driving us home. Within 30 minutes to finish what we are doing so that we can go and rest. So I'm asked to talk on multiple linear regression and interval. So, but for that we are going to talk on hypothesis also, and we end it there. So multiple linear regression. We'll be talking about regression, simple regression, beta cap, beta 1, beta 2, and the rest, our error time. And multiple linear regression is not different from what we've been doing so far. So I'll just, take us through what is different in it, and we'll close it out. So what is multiple linear regression? Multiple linear regression is when you're conducting a regression, when you're conducting a regression analysis using more than one explanatory variable. That is simply what a multiple linear regression is. When you are conducting a regression estimate using more than one estimator. So in our simple linear regression, we have beta 1 and beta 2, so to say. But under a multiple linear regression, we can have more than two betas. So which means we can calculate our beta naught, beta 1, beta 2, beta 3, and so on and so forth, depending on the variables that you have uh, you have modeled to explain your independence variable. So that's just the main difference between a simple linear regression and a multiple linear regression. Of course, when you are discussing a multiple linear regression, you have a bigger headache because you have to calculate multiple betas, and they also have their unique formulas. It's not like the simple one that you once you calculate your beta 2, you can easily use that to get your beta 1. So let me share my screen so that you can see what I'm speaking to, and we take it up from there. From okay. Hope you can hear me very well.
Very well.
Okay, I've given us the background to the
to multiple linear regression. So let's look at the specifics that we need to talk to. Although for me, I'm not expecting much question from this section of this econometrics, but I would like us to look at the in-text question that the man set for us here. The question is, why do we use multiple regression? Why? Why do we use multiple regression? And the answer is multiple regression is a statistical technique that can be used to analyze the relationship between a single dependent variable and several independent variables. The objective of multiple regression analysis is is to use the independent variables whose values are known to predict the values of the single dependent value. So why do we use multiple regression? It's simply to say that when we have multiple values, multiple estimators to determine a dependent variable, then we need to employ our multiple regression. So, for example, when we talk about our GDP, what are the factors that contribute to our GDP? What are the determinants? When you put in your inflation, when you put in your your when you put in your exchange rates and so on and so forth. Once you have more than one variables determining your dependent variables, then you have what you have a multiple regression. So the assumptions of multiple regression is also in line with the single, uh, the simple simple regression. So the assumptions are the same thing. So once you know for the for the single one, you know for the multiple. So question here is, what is the difference between multiple regression and multivariate regression? What is the difference between multiple regression and multivariate regression? Multiple regression refers to more than one predictor variable, but multivariate refers to more than one dependent variable. So Prof did not mention this in class, but you know, he may ask us this question. So the difference between a multiple regression and a multivariate regression is that for a multiple regression, you have more than one independent variable. But for under a multivariate um, regression, you have more than one dependent variable. That means you have a y1, a y2, and so on and so forth. Do you understand that? For a multiple regression, you have more than one explanatory variable. But for a multivariate regression, you have more than one dependent variable, which means the variables that you are to explain is more than one. It's a question that can that can come out. So um, so the mathematical, the econometric model equation for our multiple regression is here. You have your y1 is equal to b naught plus b1 x1 plus b2 s2 and your error time. So that is how to specify your model. Basically, what you are doing is adding a b2 to your equation. As I said, multiple and simple, they are just a matter of adding a more, one more dependent variable to your model. Um, so let me just take us to the formulas that we need to estimate our regression, so that at least we can then practice them. And for example, if there is any question on it, we'll be able to answer it also. So um, so these are the formulas. These are the formulas here. They're on page 25 in the
in the first handout, so we can just consult it. They are very simple to understand. So let's quickly move to um, interval estimation. Interval estimation. So all what we've been doing so far is a point estimation. What we'll be doing in our simple and multiple regression is a point estimation. So what is a point estimation? A point estimation is when you are picking, you know, an observation from your sample and you are estimating it. So interval simply means that you have a bound. For example, giving the example that professor gave us in the class the other time, you know, the categories of grades in the university. You have the first class, second class upper, the second class lower, so on and so forth. So that's interval that gives you the first class 4.5 to 5.0 is an interval, is a range. So and under that range, you are expected to have a actual. So for example, now if I come out to say I have a first class, what I've given you is a range. You know, if I say you have a first class in, in my undergraduate, that means you in your mind you are saying, okay, this guy is having 4.5, between 4.5 to 5.0, right? So you now ask me what is my CGPA, and I tell you that I have 4.51, right? That is the point. That is what we call a point estimation, which means that is actually what I got. It's no longer a range now, right? It's no longer an interval. So a point estimation simply gives you the exact um, the exact outcome, but a range gives you, the upper boundary and the lower boundary that your estimation, your observation actually falls into. Is when we are doing finance, we say the high and low method. How do you call it? Yeah, high and low. So you have the higher IRR, you have the lower IRR. So that is an interval. Are we together? So there are some things that we need to know when we are doing our you know interval estimation. The first one is the confidence interval. So this I've explained before. Now, when we say a 95% confidence interval, it simply means that 95% of time your result is always correct. That is what it means. 95% of time your your mean will always, will always will always occur. That's what it means. So margin of error, this is the amount added or to and subtracted from the point estimate to create the confidence interval. It reflects the precision of the estimate. A larger margin of error indicates a lesser precision, while a smaller margin indicates a more precision. So what that place is simply speaking to is that for our margin of error, that is our what do we call it now? The allowance that we give. For example, now if you are having a confidence interval of 95%, which means the margin of error that you are allowing is just 5%, right? Which means 5% of time your estimate, will be wrong. That's what it means. I've spoken to point estimate. Sample size, the size of the sample affects the weight of the confidence interval. So when you have a larger confidence interval, it affects how you estimate um, your interval. Now, if you remember very well, Professor made mention of when we have observations that is more than 30,
that is more than 30, we use our Z statistics. But when you have observations that is less than 30, you use your T statistics. So, and these T statistics, we can find them in our mathematical table. We also the Z statistics, we can find them in our mathematical table. But I don't know how Prof, will likely set this question. He may just give us, from example of what he gave us in the class, he is basically emphasizing on he giving us the estimate of beta 1 and beta 2 and the standard error so that we can then calculate our t statistics from there. Our t statistics is the our estimated beta 1, or I mean our estimated beta 2 divided by our standard error. That is what our t statistics is speaking to. So our sample will now affect our how our sample size will affect our estimation is because now if you have an observation of, let's say, 20, for you to get your what's it called, your t statistics, you have to minus 2 from it. That means if you are looking at your t statistics table, you go to um 95 under 18. So that is where you find your t statistics on the table. So our confidence level, this is probability that the confidence interval will contain the true parameter value if we are to repeat the sampling process many times. Common confidence levels are 90, 95, and 99. So in any research, most confidence level that is being given is usually 90, 95, and 99. So 90 gives a margin of error of 10, 95 gives a margin error of 5, and 99 just gives a margin error of 1. So our standard error, this measures the variability of the sample estimate. It is used to calculate margin of error. For example, the sample mean, the standard error is the sample standard deviation divided by the root of the sample size. So for the standard error, right, it is basically our observation minus our estimate. Are we together? Can we hear me very well?
Yes.
Yes,
Cloudy, please.
So I'm not.
Yes.
um, Okay, what's the question,
Cloudy,
please?
so I think from what you're saying now, this interval thing, now, I don't think it's going to be a standalone question, right? Might be an addition question
Of course,
on that ordinary least square. Yeah.
of course.
Okay.
I think it was part of the earlier things that Kazim did because I remember him solving something
That's standard error
around
something. That's why
beta, yes, around beta 2 divided by standard error of 2. That's the T statistic.
okay.
Kyle,
Yes,
can
that's
you confirm
that.
that?
Yes, yes. That's the t statistics.
Thank you.
So
Okay.
what we just need to know how to do is, Prof gave an example of he giving us the coefficient for beta 1 and beta 2, then the standard error, then we then estimate the t statistics. So in the exam, don't be surprised if you are asked to estimate your beta 1 and beta 2, and or probably it gives us the coefficient and the standard error, and we are asked to calculate the t statistics. So that is one question that we can have. So another thing that we need to uh, know is that um, anytime our t statistics is greater than 2, that is if you have calculated your t statistics, that is your beta estimated beta 2 divided by your standard error. If it's greater than 2, that means your probability is less than 5 and your result is significant. I take it again. Anytime your t stat is greater than 2, that means your probability is less than 5%. Are we with me? Your probability is less than 5%, and your estimate is, if your t stat is less than 2, that means your probability is greater than 5 and insignificant. So it takes us to um, hypothesis, hypothesis setting. So in our when we are setting our hypothesis, basically our hypothesis is um, is we stating what we want to achieve. Is we doing what stating what we want to achieve. So my usual example is I want to set I want to estimate the time that Kazim gets to class. I say it's 9 o'clock, right? So my hypothesis, my it's I mean my non-hypothesis will be that Kazim gets to class by 9 o'clock on the dot. Now my alternative would be that Kazim does not get to class by 9 on the dot. That is the alternative. So if I do my estimation and my I mean at a 95% confidence level, and I find out that 95% of time my estimation is always right, is always in class by 9 o'clock. That means I will have to accept what my non-hypothesis and reject the alternative. I'll take that again. I will have to accept the non-hypothesis and reject the alternative. So which means that my estimate, my proposition, that is the hypothesis that I've put forth, is significant 95% of time. Now, if I have done my estimation and my margin of error is greater than what I have advised, I said 95% of time, which means the margin of error that I've given is 5%. Now, if I now calculate my 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 estimate, my t statistics, and it is less than 2, if it is less than 2, that means my confidence level is low. Uh, do we understand what I mean?
Um, yes, Kyle, please, I have a question.
Okay.
Okay. So my question is, this statistic that we are doing, right? Where we say that at the point where our if our t statistic is greater than 2, it means that the probability is less than 5% and the result is significant. Is that the same thing that we call p-value?
P-value.
Yes, because
That is the
I
probability.
I used to see, yes, that's the probability value. So that's what we used to determine
Yes.
probability value, that will say that p is in that case now less than 5%. So it means that confidence level is above 95% and the result is significant. And null
Yes.
hypothesis should be accepted. All right.
Yes.
Thank you.
Yes. So, as I was saying, now that now take us to the type of errors that we have in our hypothesis. We have the type 1 error and the type 2 error. So a type 1 error is when the non-hypothesis is rejected, but it is true. I take it again. A type 1 error is when the null hypothesis is rejected, but it is true. So I have I have I make this error if I now decide to say that Hazim does not get to class by 9 o'clock, and I go with the alternative, but he's always in class by that time. That means I have committed a type 1 error, rejecting the non hypothesis when it is actually true. That is a type 1 error. Do you understand what type 1 error is? Hello?
Yes. Thank you.
Okay. So for a type 2 error is when you are not rejecting the non hypothesis instead of, I mean, type 2 error is a type is a type 2 error is not rejecting the HO when it's actually false. So now what this means is that you are accepting the non hypothesis when it is actually false, when you ought to be accepting your the alternative, but you are accepting the null hypothesis. That is the type 2 error. So I think those are the things that I want to discuss with us tonight so that um, we can take note of it. Don't forget, our point estimation is when we are estimating at a level of observation. That means you are giving a value when you are giving a figure to estimate to predict the future outcome, to predict the future value. You are doing what? You are doing a point estimation. So when it comes to interval, interval gives you, you know, a range of value. So that will be all for today. Is there any question before I close out?
Hello, Mr. Kade. I have a question. Based on the way you explained this were explained rather, but my question is in this area: is there a need for us to equip ourselves with a statistical table in case if we are to decode our final answer from the table? Is there a need, or the teacher can just give, or the lecturer can just give us, what the answer should be? I'm confused in that regard.
I think we asked that question in class that day, and it wasn't too direct about it. But what I'm expecting from him is that it gives us the coefficient, that is our estimated result, and our standard error. Then we calculate the t statistics. So let me go back to his notes, first samples of what he did there. Um, so let's look at this example too. Suppose we have estimated the following regression line from a sample of 20 observations. So 20 observation, which statistics are we using? Z or T statistics?
T.
T statistics. Why? Because our sample is not up to 30. So our estimated Y is equal to 128.5 plus 2.88x. Then our N is 20 minus K. K means the number of variables. So 20 minus 2 is equal to 18. So now from here, you use the T table. You use the T table. Say from the T table, you see the value of T 0.025 with the 18 degree of freedom is 2.10. So which means it can also come and give us this degree of freedom in the exam and say, okay, if your degree of freedom is 2.10, so hence 95% confidence interval for this parameter. So for beta 1, it is 128 plus 2.1 times 38.2. How do we get this 38.2? 38.2 is our standard error. This is what was given here. And this is the estimate, the original estimate. So which means for your beta one now, the beta one will fall between someone want to speak?
Yeah, that's
Yes?
standard error of 8.2 and that's 0.85.
38.2.
Will it be provided? Will it be given in the question like this, the way it is?
Yes.
All right. Thank you.
Yes. So now for us to now know the interval that this our beta one actually falls into is to say 2.10 times 28.2, right? So the value of our beta 1 will now lie between 48 and 208.7. How is it possible? So when you multiply these two together, you have 80.20. When you multiply 2.10 times 38.2, you have 80.2. That means the table that we are giving, what we have on our T table, times the standard error gives us 80.2, which means we are going to add this 80.2 to 128.5. If you add 80.2 to 128.5, you have 208.7, which is the upper boundary in your interval. Now, when you minus 80.2 from 128.5, you have 48.3, which is your lower interval. So which means your beta 2, your beta 1 any day will fall between 48.3 and 208.7. That is the interval for beta 1. Do we get it? So for beta 2, our estimated beta 2 is 2.88, 2.88 with standard error of 0.85. 2.10 times 0.85 gives us 1.79. So adding this 1.079 to your estimate gives you the upper boundary of 4.67. If you now subtract this 1.79 from your estimated value, you have 1.09. So 1.09 is your lower boundary and 4.67 is your upper boundary, which means when when you estimate your beta 2, your beta 2 will always fall between 1.09 and 4.67. That is just that is the interval that your beta 2 falls into. Are we clear on it? Are we clear? Or any
Yes.
question? So
Yes.
that's just all about interval.
Yes.
So now,
Okay. Sorry.
so from
Okay. Okay. So apart from this approach of the question coming, which other way do you think the question can come based on what the man said in class?
he's also giving us probability, but he said if you give us probability, that means we know the answer already. You understand? So he will prefer to go the other routes of asking us to calculate the t statistics. But if you are given the probability, that means we will know the so if you say the probability is 95%, which means your 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 what's it called now, if if I'm giving you a 95% um confidence level, right? Our margin of error is 5%, is it not? So if it now gives you 10%, 10% and 95%, you know that your model is not significant. Do you understand? Because it's above the confidence level that you have provided. So you get. So that is another way that it can come. But he's saying that that will be too simple for us. So if I'm giving you a confidence level of 90%, and I'm telling you the probability of that is 80%, which means it's still not up to you know the 90% required. But if I give you 90% and the probability is 99%, which means is what is significant. Do we get it now? Which means it's significant. But he is saying that okay, giving you that probability will you just lead to straight answer, whether it's significant or not. So we should know. Another thing is it can ask us if the model is significant or not. So we should be able to answer to that if it's significant or not. Any other question or any other area that we need to speak to?
Yes, thank you, Kayode. So for this example too, yes, are we going to be giving this n minus k equals 20 minus 2 and this from the t table to this 2.10 in the question?
So from the example two from the question, it says suppose we have the estimated suppose we have the estimated the following regression line from example of 20 observations. So when you are giving 20 observations, it's always n minus 2 for you to get your degree of freedom. You get it? So if you are giving a 25,
Sorry, does that mean that 2 is constant?
yes, for
Okay,
a simple linear regression.
for
So if you're
simple.
having a multiple linear regression, your degree of freedom will be about variables that you have in your model.
Okay.
You understand? So if it's a
Yes.
multiple linear regression, you are expected to have at least three
Three
variables.
variables.
So it will now be 20 minus 3. So it may not give us this exact 20. So if it gives you 25, you know that it's 25 minus 2. You understand? Is that clear
Yes.
now? Okay.
Yes, thank you. So what about the degree part? From the T table, we see the value of
So
T0.
is this part that we don't know if it's going to be the T tab as the table value. And that is why Professor Alabi was asking if we should bring our mathematical table or not. So for us to be on the safe side, I would probably advise, if you can lay our hands on our mathematical table, we can bring it along. That's what I would advise too. And it may be useless though. So we don't know what exactly it may do for us. But from here, it gave us the value, the T table.
So Kayode, please, just to clarify, please, the last part ends the 95% confidence interval. Sorry, is that part of the question or that emanated from the equation that was given before them?
From the T table, we see this.
Yeah. All right, thank you.
So he's estimating the 95% interval. He's estimating at 95% interval. That's what he's telling us.
Okay.
I have a question, Kayode.
Okay.
Okay, so initially when we talked about this T statistic, normally because the sample size is less than 20, that's why we're using T test. If it is less than 30, if it's greater than 30, we use Z test. But this one that we're using T test, and it's showing T that the value of T is 0.025. That C statistic that is there now it's the beta 2 over the standard error of beta 2 over the standard error of 2, right? And this T statistic is already less than 0. Does that not already suggest that the model is insignificant? I don't know if you understand what I'm saying.
Can you come again?
Okay. So you said that T statistic is used when n is less than 30, right? And as n is less than 30, we've already established that the T statistic is the beta 2 divided by the standard error of beta 2, right? And which is the T statistic they've gotten here to be T 0.025, which means that answer is already less than 2, then the probability is already greater than 5%. Does that not already suggest that the model is insignificant? If we are talking about test of significance here.
No, you are missing it up. So the actual value for the T statistics is 2.10, not this. So when this is the point, this is what you are looking at in the table, but with the degree of freedom of 18, the value that you will get is this 2.10, which is greater than
okay.
So this just where you are looking at. This is the probability on your table. Under 18, you should have 2.10, which is greater than 2.
But how did they get this value of T that they are looking for under degree of freedom
That's
of
why they
18?
gave you 95% confidence interval. I don't have the T table. I will have use the T table to explain better.
Okay. But another way that you can, like you said, another way that you can show it rather than going through the route of this table is for us to get what the T statistic is. That's the beta 2 over standard error of beta 2.
Yeah.
Okay. All right. Thank you.
All right. There's no other question. You can call it a day. Thank you for
Wow.
your time. Appreciate it.
All right. Thank you, Kale. So I think it's time for us to go now till tomorrow. Tomorrow is macroeconomics. All right. So bye bye to everyone until tomorrow. Yeah.
Thank you.
Bye.
Thank
you,
you.
Kayode.
Nice.
Thank you, everybody.
Thank you, everyone.